Great. It's 11 o'clock, at least where I am. You ready, Devin? Shall I start?
Sounds good.
Great. Welcome back, everyone who I say welcome back in case you attended the talk before. I neglected in the last talk, and I want to be careful to do it now, to call out gratitude to our sponsors whose logos are shown on this slide. We have support from a number of organizations who make it possible for us to bring together speakers like Andrew and Devin and others you'll see today and share their expertise and level up our practices, and we're grateful to all of them. Devin, I am happy to say I had the pleasure of meeting a few weeks ago at a Portland OWASP meetup. I think was probably a little preview of what he's about to say to us, and it was really exciting, and I'm looking forward to this. Devin Gaffney is a data scientist, and he is the founder of International Persuasion Machines, a sociotechnical security firm that specializes in fraud, abuse, platform manipulation, and coordinated inauthentic behavior. And he's going to talk to us about falsifying traffic data to defraud auction marketplaces. I can't wait to hear what this is going to be. It's all yours, Devin. I will relinquish the sharing.
Great. All right. So, hi, my name is Devin Gaffney. I'm the founder of a company called International Persuasion Machines, or IPM for short. I'm based out of Portland, Oregon, and as Brian said, the company is a socio-technical security firm that sort of looks at attacks that happen sort of the intersection of what is afforded to users and the sort of incentive structures that are implied by those affordances. So today I'm here to talk about a case that I found on an auction marketplace as part of my research using the toolkits that I've built for examining how people can abuse online platforms. So the term socio-technical security is not super well used right now, but I think it sort of deserves to be used a lot more. There's this really beautiful quote from this paper a few years ago talking about what this idea is, and I would invite everybody to just sort of read it for a second. But the basic idea is that systems that we've built, as they become more complicated, the focus of what it means to secure those systems is decreasingly about technical solutions, about blocking access to the database, and it becomes increasingly more about thinking about the system holistically on this sort of like cultural level of what the incentive structure is of the platform. That becomes very important when we're talking about participatory systems, where people are end users or consumers are part of this feedback loop where they are generating information that the system then uses and feeds back to other users, right? So the idea here is that socio-technical security is a sort of broader idea about thinking about what types of abuses could happen where the abuser or the attacker isn't actually violating any of the rules of the system, but is instead using the sort of affordances or things that were technically built by the engineers against the system itself. And so there's a lot of examples of this sort of stuff. The nice thing about using this sort of frame of socio-technical security, where you're saying the idea of using systems against themselves, is you can then take a lot of sort of otherwise disparate problems that are going on and put them all into this one frame. And it makes it a lot easier to think about, what are the common solutions across those, right? So we're talking about anything from the fake Twitter accounts, or, people generating fake data with AI systems, particularly with GPT-3, and maybe increasingly with the new DALL-E AI image generator, if it becomes anything more than just sort of like, surrealistic images. Political manipulation, market manipulation, there's all these types of examples that we've seen out in the world. So, bringing these disparate ideas into this socio-technical frame is, a lot of what IPM does. This case is about online auction frauds. Now, online auction frauds aren't really new. People have been defrauding marketplaces for years. So one of my favorite ones is the photo only type of market fraud, where and eBay's gotten pretty good at this, but basically what would happen for a very long time, there was different types of sellers where they weren't breaking any of the rules, and they certainly weren't doing anything technically against the code itself. They weren't intruding anywhere, but what they were doing was systematically sort of degrading eBay's marketplace by generating these auctions where they would auction off photos of the goods that they were selling rather than the goods themselves. So they would generate these, auctions where it's a Sony PlayStation 5 where you get the photo only, and you can see in the title it says photo only. And unless you're reading it very closely, you won't actually see that that's the case, right? And so there's lots of different ways that they would, generate these to sort of keep them from the trust and safety teams and try to get, bid completion and, send it out and then close up shop before eBay actually caught the account. So there's lots of these types of examples going back, 20 years. The Flippa marketplace is what I'm here to talk to you today about. Flippa, if you haven't heard of it, it's not a huge market, but it's sort of like a niche or industry market. It is a sort of meta thing. It is a marketplace. It is a website marketplace for buying and selling websites. The idea here is that you are sort of, and it's implied by the name Flippa, is that people typically purchase websites to flip them. So, it's a blog and it gets a certain amount of traffic per month, which generates a certain amount of ad revenue, that correlates with that traffic, right? And the idea is, I'm trying to find these good deals where, if I just put in a little bit of work, I would be able to, 10x the traffic and get a lot more money out of the website. And so people are, sort of buying and selling these, with those sorts of intents, buying them, refurbishing them, putting new data into it or putting new content into it, cleaning it up a little bit, making it more SEO optimized, and then selling it. So that's the sort of stuff that we're working with on Flippa. The way that buyers evaluate the websites that they're buying is they look at a few core statistics, right? What type of site, like what is it? Is it a blog? Is it like a drop shipper, which is a website that allows people to buy and, to order goods, and then that website in turn orders them from someone else. They don't ever actually have any inventory. It's kind of a shady practice. How old is the website? So how long has this, been a successful or, self-sustaining business, right? The longer it has been, the more likely it's valuable. What's the actual observed profit right now? And then crucially also, what's the traffic on the website right now? So those are the sort of like, core factors it's hard to say exactly which ones are playing into each individual buyer, right? But those are sort of like the main things that are probably playing a role in, how they place their bid. Traffic is unlike the others in that traffic can be very easily manipulated. So, obviously the financial data is coming in from an API, usually like Stripe or something like that, where it's just literally copying and pasting the financial transactions and summing them up. So it's, pretty good on transparency for that. Then there's, of course, the age of the website that's very easily verifiable in lots of different ways, from whois data to, looking at, how long is that website, going in, the Wayback Machine, that sort of stuff. Very hard to fake that. The traffic is super easy. And the reason it's super easy is because Google Analytics does a terrible job at blocking bot traffic. They have taken almost no measure in trying to mitigate any sort of Selenium-driven traffic. I assume that most people here are fairly familiar with Selenium. Some crowds I talk to are not, but briefly, it's a way of automating traffic by using programmatic means. So using not particularly fancy methods and visiting the websites from like known bad reputation IPs, Google Analytics will still dutifully report that traffic is legitimate. So I've done a lot of research looking at how systemically broken Google Analytics is. This is an example where I stood up a Rails like tutorial app on a subdomain and then installed Google Analytics on it and then hammered it with my own bots. So, you can see like the names of these pages, sample app, right? There's not 434, concurrent people looking at an account under the name Alvin Carroll at the same time on a sample app. Like it's very clearly broken, right? And so I've done a lot of work looking at like how far does this scale out, and how much money do you have to spend in order to make this fake traffic on the platform. And the answer is it kind of goes as far as you want, and it's basically a free resource to fake this type of traffic. So we know that Flippa embeds Google Analytics data as its proof of traffic, and we know that Google Analytics is broken. The next question, we need to ask a few more questions before we know that we've sort of like completed this fraud loop. The idea with this fraud, of course, is going to be, in a hypothetical situation. Let's say I go to people that sell websites on Flippa at scale, and I say, I can guarantee you that every auction you run on Flippa is going to go for $10,000 more than it has. And in return, I want $500 from that delta every time. And the idea there is that I'm going to pump traffic through to elevate the monthly active users on that property. And then once the sale goes through, I'll just dump the traffic. And so this is like pumping up and then dumping the traffic. It's a pump and dump scheme, right? And so we need to make sure that like it's actually economically feasible to do it in the sort of abstract. It seems like it would work, but is the traffic cheap enough? And do the buyers actually care enough about those traffic numbers for this to be a real factor in pricing? And so because I have this other hat as a data scientist, I pulled down something like 5,000 auctions from Flippa's marketplace, and then did some statistical regression on those different auctions. And this is from a single snapshot in time. So, it's not the most robust finding. A better finding would be looking at it over, years of data. But I found some really interesting stuff. So there's two different stages of any auction on Flippa and in a lot of auction marketplaces. The first is when the seller puts the opening bid where they want to start the auction. And then the second is where, bidders are actually putting in real bids. So I broke the data up into those two, pre and post actual bids, and looked at what's the relative strength of those factors in determining the value of those websites, right? Don't worry about the scale on this. This is sort of a relative measure of statistical sort of loading on these factors. So when you start, when these sellers start their auctions, they value the monthly revenue roughly 3 to 4 times more than the monthly hits or the age of the site. So they really think a lot of the price point is accurately described by the monthly revenue rather than the monthly hits or the age of the site. That changes when people actually start bidding. So when people actually start bidding, the bid patterns look a lot more like the monthly revenue, and monthly hits are roughly about the same value in terms of what, how it factors in to pricing decisions for the would-be buyers. And then to a lesser extent, the age of the site factors in. And it's pretty stark to see that difference between monthly revenue and monthly hits by the seller and by the buyer. So we've established that for the actual people buying these properties, monthly hits matters quite a bit. So now we have to figure out, okay, how much money are we going to spend if we're going to fake all of this traffic? And it turns out that it's extremely cheap to send fake Selenium traffic. So what I did was I generated, I can't remember, I think it was about 250,000 hits on different Flippa websites on the marketplace, and measured their responses. So about 80% of the websites that I checked off of the Flippa marketplace yielded cookies from Google Analytics, meaning that Google Analytics was actually installed. And again, we know that if we're getting a Google Analytics cookie, we're actually generating the real traffic because we saw the slides earlier. So for that majority of auctions, we can actually figure out what the cost is by measuring the costs internally at IPM. And it turns out that to generate 1,000 hits, you're talking about somewhere between 20 and 60 cents probably. So it's very cheap to generate a lot of traffic. Again, we don't even need to use proxy networks. We can just use a direct cloud IP to generate the traffic because they're not doing any sort of mitigation. And to go back to what Flip is actually showing, they're not showing anything about the broad diversity of IPs, to show each country or each physical location. They just need distinct IPs, and that's pretty easy to get with a cloud provider at scale. So the next question is this 20 to 60 cents cheaper than the amount of money we would expect to make? And I was actually pretty surprised when I did the numbers, because when you do the analysis, you have to transform everything into log space. It's kind of like a pain in the ass. But basically, the interpretation from the regressions is a chart that looks like this, where that purple line is the cost to the fraudster, and the orange line is how much money you expect to make at different scales of boosting the traffic. So I wanted to make sure that for a huge amount of variation, like from 0% boosting to 10,000% boosting, is it always going to be worth it? So the boosting here is, if I say it's 100% boosting, it would be look at the monthly active users and times it by 100, or double it or whatever, double the traffic. So in this case, we're talking about a 10,000 fold increase on the traffic. So what 10 times 100 times the traffic, right? And even when you go out to that scale, you're still making a good return on your investment. At that sort of limit, with the average property on Flippa, you're going to expect to make somewhere around $30,000 more per auction, and you're going to spend about $200 doing it. And so that's the sort of end-to-end fraud that I found. But I think it's it's again, this is just one instance of this sort of way of thinking about app security that I would love to see more of out in the world. I know that lots of people are doing this type of thing in their own way, but sort of wrapping it under this term socio-technical security and bringing it all on board as this one sort of coherent narrative of problem is sort of would be really interesting to see. And so another way of thinking about this is thinking about how socio-technical security is the sort of pinnacle of this, the current pinnacle of this increasing this relationship where as systems become more complicated and as we add more layers of abstraction on code, from the bare metal all the way out to now we're making these sort of esoteric websites with esoteric programming languages that do these things that are very abstracted from the technical matter of what the machine does, right? The further you get away from the metal, the further you get away from purely technical problems, and the closer you get to problems that are more sort of like cultural hacks or hacks that attack nothing technical in nature, but sort of like the intended affordances of the system. It's the desire paths of application security, where people are walking off of the trail and making their new trails because they just can, because you didn't engineer for that, right? And so yeah, I think it's a valuable way of thinking about this type of problems, and I'd love to talk to people about it. And if you want to know more about International Persuasion Machines, you can find the Twitter account at that address, and you can find our website at that address. We've got a ton of other research looking into all sorts of other bugs. There's a really fun one where I go and get infinite brownies for free from Panera because of a bad email design. So I'd be happy to take any questions, and please feel free to contact me afterwards.
Thank you very much for that. I'm going to talk for a minute or two while people give people a chance to formulate questions, because I don't see any in the chat yet. I appreciate your talk because it gives me, as your conversation did in the meetup too, an awareness of a path of attack, a kind of vulnerability I hadn't thought about at all. As you said, it's not an attack specifically on technological weaknesses in the sense that AppSec people usually think of vulnerabilities. It's more like social engineering software. I liked your desire paths word a lot. That was nice. So thank you for bringing to us that fresh insight of a way we should think about our work. An obvious question, I think, is probably, what can we as AppSec engineers do about it? Who's doing it right? What kinds of practices mitigate this risk?
Oh God. I think there's sort of like ham-fisted approaches to some of this stuff, right? We've sort of stalled out right now at, from a technical perspective, we've sort of stalled out at the web application firewall as the end-all, be-all, one size fits all approach to dealing with bots, right? The idea there is, add this line of JavaScript into your system or whatever, integrate this system in, and we will handle it. Don't worry about it, right? And in practice, what happens is a lot of people, will end up putting their threshold lower than they should because you're getting too many false positives for blocking legitimate users using IPs that are weird or something, right? And so, I think the sort of state of the art right now is that sort of stuff, and it's not particularly effective. I think the people who probably have the best view into this type of problem is trust and safety teams, because they're on the front lines of dealing with automated or semi-automated behavior or manual behavior done over and over by users that don't have the technical sophistication but are very angry, right? And so I think they probably have the best insight, and to some extent they might own the problem, but I would love to see more formal methods coming from the sort of more technical security side. Application security seems like a very natural place to house this sort of expertise and expand on it, right? It's just a matter of figuring out what the tooling looks like right now. And as for that, I think it's still a little early to see a single system that's doing it effectively.
We do have a question from Nell. As QA, what's your recommendation to deal with the issue? What's the ratio in technical side and manual efforts?
Totally. So I think, the QA story is, you have to try to, if you're doing it internally, you have to really try to extend yourself to being the worst person that you could possibly be, right? And really think critically about, what have we actually built here, and not think about, what is the intended path of the user, but like, where can I sort of identify those desire paths, right? So if I have, if you think about like this, courtyard with these rigid, 90-degree angles, and you see like, the door is at a 45-degree angle from where I'm at right now, right? It seems, like maybe I'll just walk that direction directly, right, and save myself 10 seconds. It sort of is, for the QA engineer, it's trying to think about, where are those desire paths that we've sort of implemented unconsciously with the system? How did we, if I'm coming into this system and I am a lazy user with one optimization goal, right? I want one thing out of this and I don't have, time to really, do anything else, right? What is that sort of person going to do? And then what is like the most malicious version of that person going to do? It takes a lot of sort of, inverted thinking about your system, where you have to kind of forget all of the knowledge that you have baked into it, from your own history with that, piece of software, in order to do it right. So it's difficult, but just try to be bad.
It sounds, as you describe it there, like the kind of thing that we could deal with to some degree in threat modeling.
Yes, totally.
Yeah.
It's about, totally, a big part of it is, when I'm describing this example, there is like a sort of threat modeling approach of thinking about a, probably single engineer that is technically inclined, that has access to Python and Selenium and a cloud server account, right? And so we're sort of figuring out like what their rough budget looks like, what their sort of profile looks like, where, what platforms they might be using. And we're starting to get it, one thing that would make this way more expensive, it probably still wouldn't make it cost prohibitive, but would make it way less profitable, would be, doing a better job at blocking cloud IPs on Google Analytics, or, for Flippa, ensuring that, all of the traffic is additionally verified by a little Selenium block or something, right? That says, is this browser actually automated, and confirming that that line is in all of the places that Google Analytics is fired on this property, right? So yeah, I think, threat modeling here makes a lot of sense of trying to figure out like, it's not going to be a state actor that's doing this on Flippa, right? It's going to be a single engineer that's trying to cut corners and make a little cash, as like a side hustle, right? And it's probably not going to be anything much more developed than that.
this is just a little side anecdote, but you got me thinking if I'd had encountered anything like this in my past experience. And I remember a system I was exposed to at one point that has suffered a little bit of fraud by individual users because they figured out that you had to log in and you could earn rewards. They could earn the rewards, then they could delete their account. And that completely deleted the account. And then they could re-register and then earn the same thing, which just had not occurred to the development team. And it's a way of thinking less about the code vulnerability and more about how, I think you called it, how the affordances, the set of available actions you can take can be combined in unexpected ways to produce unexpected results.
Totally, and I think there's a ton of those examples all over the place. One that I heard recently was at one cloud provider. They used to measure the billing, the level of granularity for how they measured billing for server costs was down to the minute. So they counted how many minutes each machine was online to make, to generate those bills. And they ended up with this really tricky problem where they ended up having to go down to, much finer granularity because somebody was generating machines en masse, like many, many machines, spinning them up, doing about 15 seconds of work, and then shutting them down before you hit a minute, and it was free. So they were almost using that cloud provider, like, it was like long-standing instances. This cloud provider, this was like a, machines that are usually online for years, right? And this person was, using it almost like an AWS Lambda setup, where they're just spinning it up from micro tasks to work on a queue for like 2 seconds and shut down. And it was completely free for months, right? And they probably burned, $10,000, $20,000 before they got caught, right? And there was nothing wrong with that. So there's nothing that they could do and to recoup those costs, those losses, right? And there's tons of examples like that all over from every engineering team I've ever talked to. There's some weird, like the type of example you're talking about, right? So.
Well, we're coming up on the half-hour mark, and I don't see any new questions in chat. So with that, I think I will thank you very much for an interesting talk, and hope to welcome you back another year.
Awesome. Thank you so much, everybody. Have a good one.
Bye, everyone, and thank you, Devin. We'll have a short pause here, well, a couple of minutes while we wait for the half hour to tick, and then we'll start off Krishna's talk.